All right. Thank you everyone for coming to the optional machine learning lesson. Um, so first of all, before we get started, I want to tackle this big question of what even is machine learning? Because you might have a lot of vocabulary words floating around your brains, a lot of preconceived notions of what machine learning is. Um, my personal take is that if you ask an average person on the street, what is machine learning? They'd probably say, oh yeah, ChatGPT, right? Like they have in the zeitgeist, this view of machine learning can be quite narrow. But there's a whole blob of vocabulary words related to the machine learning that we will dive into today. I think it's easier to define what we won't be talking about in this lesson, at least. And that is like AI tools. That lesson is a little bit later. It's actually immediately after this one. So just wait for that vibe coding one after I'm off the stage. But in this lesson, at least, we'll be talking about like how machines learn and some basic things related to that. So hopefully by the end of the lesson, you will have a better vocabulary list of machine learning related terms, and maybe even some ideas about how to apply it to your own research. So let's get into it. Um, Starting with linear regression. And this might be a little bit silly, but yes, linear regression is a form of machine learning, actually. And there's a lot of things that we can get on the same page about and extend these basic concepts to a little bit more advanced topics in machine learning. So first of all, what happens when we try to fit a line to some data? Um, when we see a data set like this that has an X and a Y axis and data that falls in a line like this, it kind of is only our natural instinct to be like, Y equals mx plus b. That must fit very well. But how does that actually work? We can take all of these random guesses when we first approach this data set, but not all of them are equally as good fit to the data. So how do we actually determine how a line is a good fit is by determining a loss function. In this case here, we have the mean squared error, which just means like we subtract the actual value of the data point from our model, or vice versa. We subtract what our model thinks the y value should be from the actual data point, and then square that. And if we sum all of that up and minimize that, that should, in theory, get us the best line. And in general, oh, that's what I just said. In general, why do we even want to do this in the first place? We want to be able to make predictions either by extrapolating out here or interpolating in the existing data space. So yeah, sorry. I'm updating the memescape of Code Astro. It is my duty because of all these vintage memes. I must I must add some new memes to the workshop. So now that we've seen a basic concept of how machines learn how to fit a line, we can extend this sort of to more advanced topics. Instead of a line, we might just talk about a model in general, maybe a neural network that has a lot of parameters. In this case, we only had parameters M and B to fit, but we will see that there's many more that we can throw at problems. Data, it could be n-dimensional. It doesn't need to necessarily be 2D. It could be an image. It could be messy. It could be noisy. It could be multimodal. Data could mean a lot of things. And we always will have a loss function, which is our training objective, how the machine actually learns. In this case, we had the mean squared error, but it might get a little bit more complicated as we will see. We always need to have an optimization procedure as well. So in this case, we want to minimize the loss function or minimize the mean squared error, but that might switch in more complicated regimes. And in general, making predictions or getting a y hat that will more generally mean performing some task. But hopefully, understanding this will be like a jumping off point for more complicated ones. Let's see. I don't know why it's stuck, but choosing the right model isn't always a trivial thing to do. Sometimes, in fact, a linear model isn't the best fit to your data. Sometimes a polynomial is the best fit to your data. Or, sometimes a squiggly line might look like it's a good fit to your data. But in reality, once you run the model and tweak the parameters, you find that maybe this squiggle is actually leading us astray. And you need to be careful of the case of overfitting to your data. So one way we avoid overfitting to data is splitting our data up into different either training, validation, or test sets, or just training and test. But the point is to train on a subset of your data and then evaluate on a test set or some unseen data. That's one way we can say, okay, maybe like this point would be held out. So we won't really follow it like a connect the dots problem. We won't be able to see that. And then when we test on it, the residuals or the loss function will be quite weird. And that'll be an indication that our model maybe isn't the best at performing a general task. And then again, here's the mean squared error yet again, but we don't have time to talk about all of the loss functions that there are in the world. You can actually create your own for your specific task to fit your needs. But in general, this is the recipe of choosing your model, defining the loss function, defining how to optimize that loss function, and then using it for whatever task you want to do. This is a recipe we will refer to in the future. But we can use these models now that they're trained in theory to do some tasks to make predictions. So for example, we've been doing this since the 1920s and 30s actually in astronomy. Well, probably since before then, but a famous example from like the 1930s is Hubble's law, where we found that the galaxy distance is linearly related to its recessional velocity through the Hubble parameter. But there are other examples on that are tangentially related to regression called classification tasks. So you might want to, for example, classify galaxies by their morphology and sort them into different groups and stuff. And both of these tasks, both regression and classification, are part of a family called supervised methods. And you might be saying, wait, I thought this was a machine learning lesson. We're just doing statistics. And my answer to that is, yeah, kind of like all of machine learning is just advanced applied statistics. But there are some more complicated tasks that called unsupervised tasks that stray a little bit farther from this statistics disguise that we can talk about and talk about a few famous examples in astronomy. So the first one is close to my heart, is anomaly detection. I work on personally the detection of anomalous transients. So when we see a light curve or a new transient pop up in the sky, determining whether or not it's anomalous is important for determining whether it's worth following up. So there's also clustering. So it's kind of in the name, but just grouping similar data together. This has a variety of applications in any regime in astronomy. There's also data generation. One famous example is given a picture of a galaxy, let's generate the physical model or let's generate the spectrum of that. There's also dimensionality reduction. You may have heard of methods such as PCA analysis. And some people actually here at Santa Cruz, I wanted to give a spotlight to this, were involved with a project called PCA, what is that, CLIP, KLIP? That is involved with detecting the first exoplanet via direct imaging. That wouldn't have happened actually without PCA reduction or without machine learning. I wanted to give a little shout out to that. There's also emulation for all the cosmologists in the room. This just gives you a flavor that there are more methods that are complicated that aren't just like statistics in disguise. I just wanted to give a flavor of examples. We don't have the time, unfortunately, to go into detail about many of these things, but hopefully some of this stuff like could be analogous to your own work and get you thinking. But with that being said, are there any questions so far on linear regression or the relationship between statistics and machine learning, or this like whole flavorful like a group of methods, so supervised and unsupervised? Are there any questions so far before we get into it? Yes.
Are you going to talk a little bit about how you split your data between validation tests?
We can. That's not necessarily. I would say for any given task, I would play around with it and see what produces good results. Usually, people say like 80 to 70% should be reserved for training, but it kind of depends on how much data you have, how complex that data is. So 80 to 70 can be a good rule of thumb, but it's not like a hard and fast rule.
Any resources?
Any resources? I love like Geeks or Geeks. They have great tutorials on all this stuff. Was there a question over here as well? Okay. Any more questions? Yes. They should be under day one. If we'll get to some notebooks together. If they don't show up under day one, you might have to get pull to make sure you have the updated version of the code base. Yeah. Simulating training sets. Yes, I love this question because I used to work in simulation-based inference. So you can use simulated data and train a machine learning model on it to understand that data. And you can do any number of tasks downstream, like applying that to real data. So for example, I trained a diffusion model, which just basically is a data generation tool on simulations from molecular clouds. So we simulated the cloud, like the observable that you would normally have, like you could observe. But this is all in simulation space. So we simulated the observable, which is Stokes parameters, and then we simulated something you can't easily observe or estimate even, which is the magnetic fields. That's really what we want to get out of them. But you can train on simulation space, and we showed that if your simulations are close enough to your actual observables, or at least you give it an honest try to get close, if your simulations are close enough, it can produce good results for estimating magnetic fields. So that's one powerful way that machine learning can be used in the simulation worlds to apply to actual real observations. Yeah.
So if the parameter that you want to end up making, if that is directly proportional to your variable or for your function instead of say proportional to the square, then how do you go about choosing the error function?
Yeah, choosing the loss function isn't always a trivial task. If they're directly proportional, meaning like y equals x, like just a flat line, I think you can still, there's not much information to be gained. I guess like if you have a parameter that isn't, sensitive, or if your y isn't sensitive to your x, then I guess my question would be why would you want to model that? Because you're not getting any information out, I guess.
No, like so if you have energy that is proportional to velocity square.
Okay,
So
yeah.
that is fine, but there could be some other variable or parameter that is disproportional to velocity instead of square.
I see. If you have other like nuisance parameters. Yeah, you can go about modeling everything. I guess we can talk later if you have a specific like task in mind. Yeah, for sure. Cool. But moving on, let's talk a little bit about how neural networks work now that we have a great understanding together of linear regression. We should be able to do neural networks together, I think. And I'll show you why. So neural networks, I should talk a little bit about like where that name comes from. It comes from actual neurons in our brain. It was inspired by our neurons, which take in complex information. They're connected to all of our other neurons. And they take in these complex signals and output some complex task, like storing a memory or telling our brain to pick up a coffee. The neurons in a neural network are kind of the same. They take in an array of connected information, and they produce some output. And that's very vague. So let's try to go through it together. First of all, we have our data input, which we saw in linear regression. It was just 2 dimensions. But in this case, we could have any number of dimensions or any number of features, denoted by x1 through xn. That just means our features or our dimensions. And we can connect them like neurons to these little things that are called neurons, which together make up a hidden layer. And the way we do this, the way we hook them up is through a weight. So like y equals m. In this case, our m is going to be changed into a w. Let's just flip it upside down. It's okay. But we do this through a series of adding these linear nodes together and then adding a bias. So it's exactly like linear regression. But I lied. It's not exactly like linear regression because we need to wrap it in this thing called a nonlinear activation function. But basically, linear regression. But the thing that actually makes neural nets so powerful is this thing that we wrap it in, is this activation function. So let's go into a little bit of what that is. They're pretty simple in principle. It just, if we didn't have an activation function, here is the linear case, which just shows a straight line. But commonly used ones like ReLU just take negative inputs and zero it out. Or sigmoid, you transform, I don't know if that's the easiest to read, but you take the sigmoid transform by putting your input in here. So 1 over 1 plus e to the negative your input, whatever that is. And that makes a nice little smooth curve like this. And this is really where the power of neural networks come from. They are able to approximate any continuous function of any dimension, given that you have at least one hidden layer. So you have one collection of neurons of, in theory, theoretically many neurons. And the big key is a nonlinear activation function. But given that combination of things, you can fit any continuous function of any dimension. Does that make sense? It's all just linear regression, but yes.
Is there a way to conceptualize what a bias represents?
Yes, we will get into that in one of the notebooks. I'm so glad you brought that up. But we will get to that in a bit, I promise. Yes. Yes.
So, by one hidden layer.
One hidden layer, that just means like one of these guys. So you can add as many hidden layers as you want. Yeah, so each of these different layers can have their own activation function. Usually it's pretty common to have, either ReLU throughout the whole thing or what have you. But as long as you have one hidden layer, again, it can have infinitely many neurons, infinitely many parameters. But as long as you have one of those, that can approximate any function. Yeah. Yes, exactly. Yes, great question. We'll also get into. Oh, yes, sorry. Oh, so sorry. Yeah. The most recent question, sorry, was how do you choose the weights? Because each of these connections, oh wait, let me go here. Each of these connections has an associated weight with it. There's also a bias. So how do you tune those parameters? Great question. We're about to get into that. Yeah, sorry, I'll try to remember to repeat the questions for now on. But this is now where we get into the lovely field of deep learning. When you add more hidden layers, that's now we're straying farther and farther away from statistics. Okay, we're becoming our own thing. Yeah. Yeah, the hidden layers are just connections. Oh, yep. thank you. What the question was, what do the hidden layers represent? And the hidden layers are just, here's another vocabulary word. They are a latent space representation of your data. So when you take your data input and run it through all of these hidden layers, you might want to do that for any number of reasons, because it maybe will reduce the number of dimensions or sort the data in a nice way. It might extract some features, in theory. But each hidden layer is just one layer that it's hard to interpret in words exactly what it's doing. But essentially, each layer has a different, each neuron in the layer will have a different feature that it represents once you run the data through. So for example, one of these neurons in this given hidden layer might encode, like, if we're doing something with dogs and cats, it might encode like, oh, this is what a tail looks like, or this is what ears look like. And then if it's a dog, then maybe like this weight will be activated and it'll go to that neuron more heavily if it like has dog ears. And then at the end, in theory, again, if things were lived in a perfect world, then you would get at the end like, oh, the neural net says this image is a dog. Does that make some kind of sense?
So, is it accurate to say that the hidden layers are some sort of a linear algebraic algorithm that the computer performs?
Yeah, essentially. If we go back here, each node is linear, which just means that your data x follows like y equals mx plus b, or y equals w times x plus a bias here. And then, of course, we wrap it in a nonlinear activation function and throw all linearness out the window. But yeah, that's kind of what you can say. Yeah.
Is it okay to say the hidden layers are just layers we don't directly observe?
Yeah, essentially the to repeat that in case, I mean, you're in the front row, but the hidden layers are just layers that we can't observe. It's kind of hard to interpret if you don't have a computer brain, which we don't, what the hidden layers are exactly doing. But that's I guess why they're called hidden layers. Yeah.
Oh, so can the number of inputs must have to be equal or less than or more than the number of outputs?
Yeah.
Question.
Yeah.
Second question. How do you choose between the activation function? You mentioned like, oh, you can relative or throw out the narrow not part, or you can pick and choose. So how do you pick and choose?
Yeah, the first question was, does the input, like the number of dimensions in the input, need to match the output? And no, like in theory, you could have an image that you flattened like 100 by 100 pixels. So your input could be 1,000 and your output could be just classifying whether or not it's a cat or a dog. So your output dimension will be like 1 or 2. So no, not necessarily. There's nothing in the middle here except for the first hidden layer that has to have a certain amount of dimensions at all. And then the second part of your question was, how do we choose an activation function? And this isn't necessarily a question that has one answer. I'll throw the ball down the line and say that in the notebook, you'll explore what the choice of different activation functions has. So maybe you'll find out that question and you can tell me. Yeah.
So wait, should all activation functions be bijections or not necessarily?
By bijections, sorry, the question was, should all activation functions be bijections? And
then it's always increasing,
Mhm.
if it's on the signal as well, or the error function.
Yeah.
That always be the case?
Should that always be the case? Oh, that's a great question. I don't know. I don't know. Honestly, that's a great question. Does anybody have anything to say about that? Yeah.
It's really big T for math reasons.
For math reasons.
Otherwise, the network can have two solutions because then it can go either way. Like if you imagine a leaky value with a negative slope, and then the model will have reduce the same solution with the wave. So I
Yeah.
think the answer is
Okay. For those on Zoom, yes. For math reasons, probably.
Oh, the inverting
The activation functions have to be bijective. These are great questions, though. Keep them coming. All right. Awesome. So let's keep on going. How far did we get here? Let's see. I think we got to deep learning, right? Yeah, we got to this meme checkpoint. All right. So now we're in the regime of deep learning. Woo! But the recipe is always the same, right? We choose a model. In this case, we're choosing a neural network. We're defining a loss function, which we discussed kind of can be complicated, but sometimes if you have like a regression task, it still can be our tried and true. We know her well, MSE. And we optimize the parameters generally a bit different because we have a lot of them. So we use this regime called gradient descent, which I'll talk about in a second. And then still we evaluate on unseen data and do whatever task we want to do. And if I'm talking too generally, like feel free to stop me. I can always give an example that makes things a little bit more concrete or easier to understand. But there was a question earlier about how do we tune these weights and biases. Initially, we will have a random guess, just like we guessed in our linear regression regime. We'll set all of the weights and biases to just be completely random. We have no idea going into it what the weights and biases might be. So we will set them to be random. And the way we optimize them is through this gradient descent regime. So basically the recipe is change the parameters a little bit. If it, let's calculate how much the loss has changed. And if it makes the loss go in a good direction, then we might go a little bit farther in that direction the next step. But we want to be careful that we don't get stuck in like a local minimum because there might be solutions to our neural network that fit the data, but we won't be able to get out of them because we've gotten stuck. And then repeat. And it's important to talk about the learning rate because we don't want to take these really big steps and then completely miss the solution. The learning rate dictates how far we actually get to go on each step. And this is why I learned neural nets take so long to train because you have to tune so many parameters at once, take little baby steps in each of them. And it's usually a very slow process. But let's try to do it together. We have about a half an hour left. So let's maybe take 20 or so minutes actually using a tool. I didn't know really what level people were coming in with. So I gave us a variety of tools that we can play with. If you get bored of one, just move on to the next one. So I love this web tool, first of all, called the Neural Network Playground web tool. There's a link to it if you have a copy of the slides, but if not, just Google that and it should come up. It's great, and you can tune a lot of things about a simple neural network to fit a simple data set and just press this play button up and in the corner. And it's a great visualization of a neural network. I would recommend just tweaking one thing at a time to see what is different or what changes. And then maybe two things at once. But if not, if we want to get more into what neurons do or what activation functions do, I'd recommend going to the neurons notebook. That actually shows you, like, given one neuron, what can you do with that? With one neuron, basically, you can get one step in a function. So if you have two neurons, you can get two steps towards fitting a function. You can imagine, there's no data here, but you can imagine an arbitrary function that you're trying to estimate, and how we build up to that. But if you're like, I'm a pro at this already, I just want to go right into training a neural network, you can go into this MNIST notebook, and MNIST is just a data set of handwritten digits that you can, in this notebook, you can build your own neural network. It might take a while to download and to train. So if you get stuck there, feel free to go back to those other tools. But I think the plan is that we'll come back 10 minutes before the hour's up, and then we can go through the tools together and see what we learned. It looks like a lot of you had fun with the playground, the neural net playground. So is there any lessons learned from that anybody wants to share out? Can try to bring it up and play around with it. See. Any fun stuff to note? Yeah.
And it's for fun, ranked up, number of layers and things, and it
Yeah.
overfits extremely well.
Yeah. How do you tell, pop quiz, how do you tell if it's overfitting?
Because the validation loss is much higher than the loss.
Yes, exactly. So here, how do you turn on the test loss? I can't see from my angle. Here it's only plotting the training loss for now, but I think there's some option probably. I thought I saw it on somebody else's laptop where you can have the test loss, which is how you tell. Oh, they are plotting both of them? Oh, well, that's great. That means we're not overfitting. Great. All right. Any more fun stuff? Yeah, Patrick? Yeah, so for Zoom, when we're fitting the spiral, we needed the linear and the sine activation functions, yeah, to fit what's going on there. Fun. All right. With the remaining time, maybe then we can go through the notebooks together. Hopefully this works. Oh gosh. All right. Actually, let me try to mirror my screen and hopefully it doesn't break things. Okay, so let's speed run through the neurons notebook. Get rid of this. Or not. It's very stubborn. We'll put her up here then. All right. All right, neurons. What do they do? How did they get here? Let's make sure this can run. Awesome. It always goes wrong when you try to do it live, right? Anyways, did anyone, I'll ask a better question. I'll do this in a better way. Did anyone try to run this and did they learn anything from this notebook? We only have 5 minutes left, so maybe a live demo isn't in the cards for us. In theory, this should have shown, if anybody gets it to run, it'll show you how, which parameters, either the bias or the weights, how that shifts where you can make your decision boundaries. So it should show, spoiler alert, that if I get this right now, the weight, or the S parameter, which is like it's basically the bias, that'll tell you where you draw your boundary. Let me get the this back. It'll show like if you set S to 0.2, that would mean okay, your function starts working at 0.2. Versus the weight will determine how sharply this boundary actually is drawn. In short, so if your weights are a little bit weaker, then it'll look more like just a normal sigmoid function or whatever your activation function is. It'll be a little bit flatter and floppier. Versus if your weights are higher, then it will be very active right away. Yes.
I mean, it's so hard to just know what number.
Yeah, exactly.
So
Yeah.
I mean, really proud.
Yeah, initially you just give it a random guess, and that's where the magic of machine learning comes in, is it learns like, oh, this is exactly how and where to draw the boundary to do my specific task. So that is the magic of machine learning. With the remaining 3 minutes that I have, did anyone get to the MNIST notebook? I know there were some downloading issues and some package issues, but how did that go? What were the lessons learned from that? Anything? Did we train a thing? We trained a thing, and that's a win.
There was
Yes. There was a typo. Okay, please let me know about that because
frame loader.
Okay.
The variable.
Oh, okay. I'll take a look at that. Thank you. Yeah.
High level question?
Yeah, of course.
What should you look for to know that you have a problem that is well tackled by machine learning versus not?
Ooh. The question is, how do you know if your problem is well tackleable by machine learning? How do you know machine learning will work? And I think I'm going to answer this in a dumb way, but you never really will know if it will work until you try. And usually it's great if you have a very low dimensional, a very non-noisy data set, but that often is not the case in astronomy, as we know and love. So you never know until you try. But now, hopefully, maybe you feel a little bit, we're a little bit more empowered to tackle these things in machine learning and do the trying. Yeah. Awesome. Any more concluding questions before I flash some more terrible, terrible memes on the screen? That kind of summed up what I wanted to conclude with, was saying, like, it's not magic, it's machine learning. And hopefully now this is you, the scientist who can see deeper and now sees that it's all just linear regression, it's all just linear algebra. And here are some extra resources I want to give a quick shout out to, especially this textbook, very great resource. There's also this active lecture and seminar series on AI and ML topics led by NASA. And again, if these should be on the GitHub repo, all of the slides and all of the materials are on the GitHub repo. So if you want to follow the link later, this one also I haven't read in detail, but it has a lot of links to domain-specific use cases of astronomy. So you might find something that is related to or kind of looks like your work in astronomy from this paper. But definitely a big shout out to this AI Scientific Technology Interest Group. They have all of their lectures recorded and posted on a GitHub. Yeah.
I would think an interpreted language would be a very slow way to go through the code. If you want something on C++.
Yeah, there are definitely the comment was like this might be a very slow way of going about it, and maybe some structures like languages like C++ might be better or faster at running this. And definitely, I would definitely encourage you to explore. And if there isn't a tool in your that exists, I would encourage you to make it. Yeah, that would be great. Okay, any last comments or questions before I give it up to the vibe coders? All right. Thank you guys for being such a great audience.
Okay, let's get started. So we're going to talk about vibe coding, which we got some comments last year that people wanted to learn about this. So this is our kind of demo tryout of a vibe coding lesson. I had to make a new meme, so I looked up what was the oldest meme on the internet, and then I think there were a lot of different opinions on what was the oldest meme, but I thought this one was easy to use. So there's your new meme that's also a vintage meme at the same time. Okay, yeah, so let's talk about vibe coding. So what is vibe coding? Maybe just to do some definitions. I feel like this is all stuff that's happening in the last year or two, moving very quickly. We're defining vibe coding as using artificial intelligence, AI, and in particular using generative AI, such as those based on large language models, to generate source code automatically by prompting AI tools. And these prompts don't have to be very specific. They only have to provide the general quote-unquote vibe of what the user is looking for, and are generally written in a natural language such as English. You're not writing in a programming language, but you get outputted programming language. Some of these tools are can be described as AI agents or agentic AI. Have you heard these buzzwords? These are buzzwords people use to make money. Typically, this usually means that the vibe coding tool is able to go beyond just generating code from a prompt, but also able to, on its own, kind of automate, plan, and oversee the coding themselves as well. So it's not just, here's a prompt, here's a tool. It's like, here's a prompt, here's some code. Let me look at the code and decide if this code is correct, or if I need to modify the code. Let me look at that code and decide if it fits the right style of the code base. Let me look at the code and decide if I need to write tests for the code. So that's kind of the level of agentic AI. It's like a second level of like both not only producing the code, but also reassessing the code and seeing if it can be improved. There's like some deeper level of automation or decision making involved. That's usually when it's called agentic or AI agents. There are a lot of AI offerings out there. If you guys follow the news, this is like basically what anyone that this is what like it's in the news all the time nowadays. But there are many AI services to use for vibe coding. You might have heard things like Google Gemini, Anthropic's Claude, ChatGPT, Microsoft Copilot, etc. Some of these some of these are free, some of these are paid. In the context of just software development, some of these have, people try to use them in many different ways, but we're just talking about in the purpose of software development. Uh, some of the main differences between them are pricing. Some have free tiers, whereas some others, such as Anthropic's Claude Code, which you might have heard about because a lot of people in software development use it, do not have free tiers. You have to pay for it. For paid models, some are flat fee, like monthly subscription fees, while others are based on usage. Um, for model performance, that's another kind of distinction between these models. Some of the more advanced models generally perform better, but they're also more expensive to run and are slower. And the free tiers often only give you access to the most basic models, whereas the quote unquote frontier models, these like really advanced, largest models, most expensive, burn all the carbon dioxide that you can possibly find, models can sometimes do more sophisticated tasks. These models also have different levels of context awareness. That's basically saying, how much information about your project do they know? You can, interact with things like ChatGPT through the chat window, and then, from that chat window, it only knows about what you've put into the chat window, right? There are services that are integrated into IDEs or onto the command line, such as Claude Code's VS Code integration. That one can read your folders and your files and understand the code, understand the context of your code and how it interacts with other pieces of software. And then, there's sort of things in between, like uh, Google Gemini's Colab integration. It can access your entire Jupyter notebook that you've opened, but that's the only thing it can access. It doesn't see the rest of your Google Drive. It doesn't know what else is going on. So it's this. There's also differences in allowed capabilities. So it's like similar to context awareness, but it's more about what kind of permissions do they have. Some these AI agents can only output chat prompts. So you ask it to produce code, it will only output some text in a chat prompt that you can copy and paste and put somewhere else. Some can directly modify your code, your files directly. Some can even run arbitrary lines in your arbitrary command line commands. This can be very powerful for automation because it can execute, with your permission, arbitrary code. It can follow up links. It can look up information by itself, whereas other ones cannot. But this is also dangerous because it can also do anything to your computer. It can execute anything that you can execute on your computer. So. These are some of the trade-offs. These are some of the ones I kind of came up with. I don't know if anyone else who has experience with these, if anyone else has any, does anyone else have any other kind of they think are differences or distinguishments between the various AI agents or AI models that are out there? Anyone have any anyone can come up with any other distinguishing traits?
Multi-model.
What does multi-model ability mean?
Images, documents, videos, other than text.
Analyze things beyond text. Documents, images, videos. Yeah.
So I don't know how to call that, but for example, you can have a ChatGPT account. It will your agent will sort of go through all the prompts that you made in the past, and then it can tailor the answers to your typical interests. So I can like make you prompts about make it bigger about that does like X versus Y, and it'll like do something exoplanet related because it knows X and Y planets.
Yeah. So, what kind of data do they know about you? Generally, all of these AI agents, if you've worked with them, have saved your entire chat history with them. So don't think of it as chatting into the void. It is chatted into recorded history that will be used, whether you like it or not, probably. Anyone else? I'll say this one about analyzing things beyond text. This is kind of one of the kind of big leaps in the technology is using this idea of tokenization, being able to basically transform anything into tokens. And this allows basically these. You also maybe hear about this called quote unquote multimodal, being able to produce or analyze many different kinds of types of data by being able to tokenize and transform them all into some sort of standard type. Yeah.
Can you clarify?
Tokens are just some sort of, you know how we talked about hidden layers and latent spaces and how the machines kind of convert things into other things machines only know and we don't ever know about? Tokens are like that. It's just converting things into a representation that it can understand. It standardizes all representation into a certain representation, but what's that? Sure, it's a vector of numbers and at the very underlying level, but everything is a vector of numbers at the very underlying level, right? Like images are a number of vectors at the underlying. Yeah, part of the these AI models is this process of being able to convert many different data types into a kind of standard data type that it itself understands, which is called tokens. And it's part of the kind of the middle layers of what happens in these AI models. Okay, so if you came here to learn about how to vibe code, I have a very, very, very short lesson on how to vibe code. Vibe coding is inherently a low barrier to entry task, which is why it's kind of called vibe coding. Because of that, this lesson does not provide many instructions to teach you how to vibe code, but we'll rather, for the most of this lesson, talk about the philosophy, the process and philosophy of vibe coding, and how it kind of intersects with astronomy software development. So we're gonna focus less on the how because if you haven't done it before, we're gonna do a quick activity, and then you've learned almost everything there is about vibe coding. And then we'll talk a little bit about like how to vibe code in the context of astronomy software development. So we're gonna on your own. We're gonna spend maybe about 10 minutes on this. So everyone can do this. The first activity is just to in this morning, we did that programming paradigms activity where we made the free fall gravity simulator. And we did it on Google Colab. So we're gonna reopen up that exact same notebook on Google Colab. You can open it up on Google Colab. You can do that by going to our GitHub. You can go to day 1, and at the bottom we have our README, and one of them is the Colab link to the code developing workshop. And there you can notebook, and you can go there, and we're gonna redo this free fall particle simulation that we did this morning by hand because we had all our AI assistants turned off. But we're going to do it with Google Gemini and vibe coding. So how you're going to do this is you're going to open up the notebook. You're going to click on the Google Gemini logo at the very bottom. This would open up a chat prompt with with Google Gemini on the side, and you're going to prompt it to. We're gonna have you do a couple things. First, you're gonna prompt Gemini to complete the free fall simulator, which is in the first 2 code cells. After you do that, review the solution from Google Gemini. Since you guys just did it this morning, you guys have a deep understanding of what you want the solution to be. So review the solution from Google Gemini. Do you agree with it? Were there any mistakes? Was there anything it could have done better? And then if you can complete that, prompt Gemini to address the following GitHub issue. You can click on this and follow the link. I made up this fake GitHub issue. It's called Fixed Spelling and Grammar Issues in this code developing the Jupyter Notebook. There are definitely some spelling and grammar issues. Someone should fix them. So you should prompt Google Gemini to fix the spelling and grammar issues in this notebook. How did it do? You sort of review any corrections from Gemini. Does it work? How did it do? Do you agree with them? Were there any mistakes? So let's just spend the next 10 minutes. Just do this on your own. See if you can get it working. See how it goes, and then we're gonna do a little quick recap after the next 10 minutes. Questions? The question is, do you need to make a copy of the notebook? No, you can just execute it. You will not be able to overwrite our original notebook, so you can just execute it. Yeah. All right, so let's do the next 10 minutes. So we'll come back at 25 minutes after the hour, and we'll see how you guys do. Okay, I don't see anything else. So seemed like people were pretty successful, right? Um, raise your hand if you were able to complete the free fall simulator with Gemini. Wow, very good. How did it do? Did you notice any issues, or was everything perfect? Perfect. Perfect. It added a bunch of functionality you didn't tell it to. Okay, good. That's something that's worth keeping in mind. Someone else, Rebecca? Yeah, it's very aggressive about white spaces. Yes, yeah, overzealous. Yeah.
I had it try and sort out what happens when the height's below 0, and it just had a place. It gave a placeholder instead of actually doing anything. It said, look at 0 and said you can do actual interpolation here, and it will. You didn't actually do anything.
So you told it to do an edge case, but it kind of without further guidance, it kind of produced nonsense kind of thing. Yeah. Anyone else? Yeah.
It's kind of a small thing, but it actually created the variable new height and then assigned it to the new height. So it kind of creates a new variable that could be optimized.
Yeah, so it maybe didn't find the most elegant solution. It found it kind of it created a bunch of it created a new variable which was unnecessary, but the code still worked, kind of thing. Yeah. Good. These are all things we'll talk about a little bit more about kind of these issues and best practices further on. How about the second one? Were people able to use Gemini to successfully address issues 232 about the spelling and grammar? Raise your hands if you're able to. Oh, less people. If you were for the folks who are not, did you need more time, or did you run into technical issues with it being able to?
Took a detour.
What's that?
I took a detour.
You took a detour. You said to do other stuff.
Yeah.
Okay, that's fine. Yeah, it's okay. It's okay. It didn't sound very exciting. Was the solution generally good? Did you find any issues or in its editing of the text? Yeah. Yeah.
Grammar stuff, I wanted to like tweak the wording
Uh-huh.
that it, I guess, thought was better.
Yeah.
Also, it was really nitpicky about things like, oh, there needs to be a period at the end of every single sentence on a bullet point.
Mm-hmm. Mm-hmm. Yeah, so it was maybe going beyond just spelling and grammar editing, but actually like editorial rewriting in ways that it wanted to, and maybe again overzealous in various stylistic ways that you maybe didn't want it to be. Yeah. Yeah.
But I found was that it actually took less than 30 seconds to
Mhm. Yeah.
But it even I just like copied what the
Yeah.
prompt that you
Yeah. Yeah.
stated. And actually what I got was the different categories of the mistakes it found.
Yeah.
The capitalization ones and then the spelling ones,
Uh-huh.
then grammar and word choice.
Uh-huh.
And like one by one bullet pointed everything.
Mhm.
Like even suggestions that she mentioned, like,
Yeah.
that what sounds better, what
Yeah.
doesn't sound better, and overall it performed probably a better work than I would have expected.
Uh-huh. So it performed better than expected because you just copy and pasted the prompt directly in, and it just ran in 30 seconds, and it gave you it not only edited, but even gave you a summary of what it changed. Did anyone run into the issue saying that it can't edit the file? It was actually funny because I was beta testing this, and I ran this multiple times. And the one time I demoed it for the TAs, it said that it wasn't allowed to edit the text markdown cells. And every time I kept asking to try again, it just refused. Just that one time though, and then I restarted it, and it was able to modify the text files again. So yeah, so you can see your mileage may vary, maybe not fully reproducible. You can see that, sometimes it's overzealous in some cases, but sometimes it does produce good work, and there are specific use cases where it potentially has an application and is effective at certain cases. Okay, so that was Google Gemini. You saw it. You kind of had to copy and paste things in, but it was able to edit your notebook, which was nice. Now I'm going to demo Claude Code if you guys haven't seen Claude Code before. Claude Code, I'm going to ask Claude Code to do the same grammar and spelling thing that you guys just did. So Claude Code can either be run on the terminal or there's a few integrations into IDEs like VS Code. So we have integration into the I have the integration to VS Code set up here, so we can take a look. So actually, I don't even want to do it this way. I'm going to do it this way. We're going to start up a new chat prompt over here, and I'm just going to copy and paste this, handle that, and you can see that's and basically it's basically running, and you'll see that it's going to run arbitrary command line commands. This is the GitHub command line tool. Normally something like Gemini wouldn't be able to run a command line tool, but it is Claude Code wants to run command line tools, but with the default settings, which I keep, it will always ask you for permission before it runs any arbitrary command line tool. So I'm going to say yes, you can view that issue, and you can see what's happening under the hood. All this like thinking stuff. You can click on it and it expands. It says, oh, the user provides something. I need to go. To handle this GitHub issue. Let me look at the issue first. And then it says the user provided a GitHub URL, not a PR URL. Let me fetch the issue details using the GitHub command directly. So it figures out from this. This is how agentic AI is. It figures out that it needs to then run a command that's like this gh issue command to view the issue text. It gets the text. It figures out the notebook. Then it says, then it starts like, let me read through the notebook to figure out the spelling grammar. So it figures out what the next step is, and it will then read the whole notebook, and then it identifies a bunch of issues. Again, normally this is all collapsed, and you don't even see this basically. It will go through and edit the cells, and you can see it's editing the cells one by one right now. It's all happening. Every one of this is at least one prompt into like a chatbot. Like every one of these little sections you see where I expanded things, that's like prompting the chatbot once, but it's all doing it automatically. And also to note that every time it does this, it's not just like the next. It's basically feeding, just like a chatbot normally is. It feeds the entire previous history, conversation, outputs as input into the next message, right? So that's the only way these LLMs know context, is basically feeding the entire chat history into the next output. So every time here, you're basically feeding all the previous things that have been inputted and outputted into the chatbot's history. So it's still running, but it's basically editing the code right now. You can see it's editing the code directly, just like Google Gemini. It has write access, so it's not just like producing snippets that you can copy and paste. It's directly editing the lines of code.
And my concern is always if I let it directly edit code, it might introduce something that I don't recognize.
Yeah, we're going to talk about that shortly after this demo. But I generally let it edit my code, but I have some rules afterwards. So here you can see that it has finished editing the code, and just like how one user said for Gemini, it produced basically a whole table of, this is the things I edited and this is how I edited them. Okay, so that was Claude Code. It just gives you another kind of showing of how not only is it just like a chatbot, but this is where we start going into what's called agentic AI, where it starts automating itself and overseeing itself and tries to handle higher level tasks and break up that higher level tasks into smaller granular tasks for itself to do. Okay. Now that you've done it, and maybe you guys have heard about some of these things, let's maybe crowdsource as a group together. What kind of concerns do we have about vibe coding? I just heard someone ask about, editing the files and introducing errors that we didn't intend, right? That's one concern that we have with these tools. What other kind of concerns? Yeah, right here.
Really not suitable for like large scale projects. Like the AI is really bad at understanding the position or the role of a certain function or certain class inside a massive project. When you have bipolar projects built like that, the pieces don't communicate together very, very well. It's very hard to deal with.
Potentially bad at large scale projects, producing suboptimal code bases. Okay. Other issues, concerns? Yeah, in the back. hallucinating. Uh-huh. Yeah, I can't spell hallu. This is why I need spell check. And you can see all the notebooks I wrote in Code Astro usually need some spell check. Hallucinating. Okay, making things up. Yeah, that's one thing we worry about. It's like it pretends that this fact is real, but it has no basis, but it decides that it sounds as real. Yeah. Uh-huh.
Oh, if I go and use machine learning,
Yeah.
set all my tokens immediately on something.
Well, I burn to do this tiny task. It's very hard to understand resource usage and the AI. Companies don't make it transparent. Okay, we're not there yet. Okay, let's keep going. Anyone else? Another one? Uh-huh.
I always follow my own capacity.
Uh-huh.
And I get in that value period by not doing that.
Uh-huh. Losing training of one's own skills by auto. Uh-huh.
Sort of in the same way, knowledge debt for people who are developing.
Knowledge debt. So basically like not knowing how something works because the AI always did it.
That
We're losing our understanding. Yeah. Privacy of user data. Uh-huh. Yeah. Yeah. Privacy of user data. Companies uh, can store a lot of it, but the user doesn't know what is stored. Uh-huh. Yes. Oh, yeah, one more.
I find it very hard to work with these packages that are not like popular.
What was it? For it's hard for it to work on packages that are not popular.
Yeah.
Well, on niche, less popular packages that maybe has less training data available that I can blindly copy Stack Overflow from. Okay, good. These are some good ones. These are definitely things, and we'll address some of these in kind of some best practices that we'll talk about in a second. Oh, dollar signs don't work. Okay, let me just a second. Good. There we go. Okay, there's also, here's a list of kind of real technical issues that I kind of compiled together that's, caused by vibe coding or specifically, I try to do as much specifically as vibe coding and less just general AI. AI agents without proper safeguards can be really dangerous. We've had incidences of companies' entire databases being deleted by AI automation tools that had no safeguards on them, or AI's tools holding important credentials and access, such as like your passwords, your access tokens, and then those AI tools being exploited and having all those access tokens being leaked and basically causing security breaches. These are real incidences that have happened in the last year, I think. There's concern generally about code quality from AI, so just as some of you brought up about the quality of the code produced by AI, and maybe you noticed that maybe some of the code produced by Google Gemini for our collab notebook that we just did, there might be just little bits of code that are not so good, but those little bits of code can build up over time and create things like technical debt. And so this is, some companies are also warning about AI slop and trying to combat that. There's new code contributions, particularly for open source. This has been a big issue in the last year. Is new code contributions created by AI tools are basically swamping open source code maintainers. Oftentimes it's like a one or two people doing it from the goodness of their hearts, right? Who have to review and quality check these code. This is causing developers to burn out. So basically causing people to stop developing open source packages because of this. And it's also causing some other developers to close the gates on who can contribute. So basically only allowing a select group of people who they've already vetted to allow to contribute to open source packages, making it less open. But these are practical concerns that things that people have been doing because of this problem. AI coding tools have also been finding security bugs, basically sometimes swamping security experts with possibly duplicate, possibly already fixed bugs. So basically, like many companies and many big tools have these bug bounty programs where you like are incentivized financially to kind of report important bugs. But those kind of programs are now being inundated by people just running AI tools, trying to find bugs and then trying to make a quick buck by finding important bugs, but basically usually they're just finding bugs that people already have found. It also lowers the barrier to security exploits and causing people to hack various systems easily. AI tools can also circumvent open source copyright. One of the key things, we'll talk about copyright a bit more later in this class, later in this workshop, but there's a type of copyright called copyleft licenses. So basically any derivative of an open source tool must remain open source if you are releasing the code under this copyleft license. And nowadays, with AI, people are getting around this by basically having the AI tools do a complete rewrite of the tool. So maintain the same functionality, but completely rewriting the tool. Something that would have taken many developer hours in the past, completely financially infeasible, but now people are doing and basically getting around various current copyright issues. And also AI sometimes is producing code that is almost exact replicas or copies of code that exists out there that is under copyright. So this is basically producing duplicates that maybe are too close to be even considered fair use. So that leaves you open to copyright infringement. AI in the job market is threatening a lot of entry-level coding jobs, and we're seeing this right now and statistically just seeing the drop in the number of entry-level hires as companies think that they can save money by using AI tools instead of hiring people and training them. Data centers are a huge issue with AI. If you want to, these are all links, by the way. So if you open this, you can read a lot more about all these things. There's like 6 links in this data center section. There's this huge data center boom because AI is very resource heavy. This is taxing the energy infrastructure. This is taxing the water infrastructure. Because of this, companies are actually like using portable gas generators to power these AI data centers because they don't have enough power from the municipal grid. These portable gas generators are basically polluting the nearby people who are living next to the data centers are getting polluted by these portable gas generators and actually making people sick. This is happening across the US right now. And also these data centers also cause noise pollution, which also have been inducing health issues as well. So we'll talk even more about this and the ethical issues related to AI, especially how they relate to discriminatory practices in software on Thursday. But we're already getting a little bit of a taste of that here. The true costs of AI are probably not reflected in its current pricing. Recently, as these companies are going from trying to get people to use these tools to actually trying to make money on these tools, you're seeing a drastic increase in the pricing of these, sometimes 10 to 100 times more than what people originally were paying. And this is probably more like the actual true price of these tools. So it's probably 10 or 100 times more than what they're being advertised for right now. And then folks have also brought up here, data ownership and data protection to AI is hard to control when your prompt, what you're giving to an AI is being saved and can be used by others, and it's data that's outside of your control. Basically, it's at the control of these companies, basically. So these are kind of real and technical issues. Like I said, we're going to talk more about the kind of discriminatory aspects of AI on Thursday, but these are kind of real kind of issues that are brought about in the vibe coding landscape that we have to kind of recognize that are things that we must deal with in order because some of these are completely unsustainable. Like we are relying on open source code, especially in astronomy, and this is causing severe stress on kind of popular packages like NumPy, SciPy, things like that. Yes, question.
So Is it your feeling though that the enormous investment that's going into this race right now then just can't possibly pay off?
The question is, do I believe that the enormous investment in this race is going to pay off? And if I knew the answer, I would be making money on the stock market right now, and I don't know the answer. I can only tell you that there are issues, and there are this enormous growth is straining many things like energy infrastructure, water infrastructure, people living, especially marginalized communities living in particular areas where they're building these data centers. But whether that's going to eventually end up with a positive dollar sign at the end, I don't know. Yeah.
There's actually a lot of some academic institutions of actually making AI more central to what they're doing. So Manchester, my university, has partnered with Copilot to have private, so their code doesn't go elsewhere to
Yes.
models around that.
Yeah.
What's your opinion on like institutions moving to accept it rather than sort of work against it? Kind of thing?
Yeah, we're not. This is not going to be a lecture on me advocating on various policy issues because I'm not qualified for that. Certainly, one of the things that is happening in the data ownership thing is companies who are usually paying a much more expensive fee for these subscriptions than what you see as a commercial. So, like, if you like go to Copilot and see what the billing rate for you is, or go to Cloud Code and see what the billing rate for you is, you're like, oh yeah, I can afford that. But the company rate for all these products are usually much more expensive. And part of that is because they get to say that, Anthropic or Microsoft doesn't get access to their data and protect it. So that is the thing that's happening. It addresses partially. I mean, companies are always been very protective of their data, but the same thing isn't happening in the user personal space. You have one more? You have one more, and then we'll move on.
Yeah. We talked about sort of using it for prompting, but it's also something used for like IntelliSense or IntelliCode suggestions as well. What's your opinion of that? Like, well, it could speed up productivity of people who are sort of already qualified for that, if that makes sense. Not just sort of lowering the bar, but actually being a tool used by workers to increase their productivity as well. Is that something considered? Yeah.
Is AI useful for increasing productivity? I think the answer is definitely yes, especially in the software landscape, which is why we're showing you a little bit about how to vibe code. You've seen there's actually very prominent open source software developers like Linus Torvald who created Linux. He is kind of really at he's one of the person that's kind of at the we're seeing both the pros and cons. Again, Linux is a operating system, open source operating system, right? It is being inundated with new AI pull requests for new features. It's being inundated by AI security bug fixes that is basically completely making it unsustainable in some ways, or really stressing their development. At the same time, like it's also fixing bugs, finding security patches for them that they hadn't found for like 30 years, 40 years of Linux development. So it has, there are productivity improvements, but there also are issues with it, and both are true at the same time, I would say. Yes. Sure.
So I work at NASA Goddard, and I work on this mission called Pandora, and we have this document called the Payload User's Guide, which is 300 pages of intense technical jargon. And every time we want to figure out, like, what is the angle of this, star tracker on the spacecraft, we have to go dig through 300 pages of documentation. So someone on my team took the Payload User Guide, embedded into a basically agent, which is internal to NASA because it's also information controlled by the US government. So we have to use some internal GPT sort of thing. But it basically turned it into an advanced search bar, basically. So we like embed it into it, and then it has the entire payload user's guide in context. And now when we want to know, instead of having to do a really fine-grained search for terms that we aren't quite sure what they are, we can type a description of, we're looking for this, that, and the other, and it will return more quickly. So that was like a very, very practical efficiency improvement of just like, AI is very good at knowing the whole context of the thing and then returning information. But we ran into a problem 2 weeks later when we ran out of tokens and could no longer use the agent. So like that's like some of the give and take. So it's like really fantastic for this task until we ran out of resources.
Yeah. Yeah, so for folks online, Ray just gave an example of AI using as a tool to basically parse a giant, very complicated technical document and search through it efficiently. But the con of that is that it uses up a lot of resources and tokens, and after a month, they ran out of tokens and couldn't use the tool anymore. So yeah, there's definitely, I don't think anyone can say that there's no benefits from AI, right? It's just that there's also issues created by AI. Moving forward, you guys did some vibe coding. I heard some people say, this is dangerous. This is so easy. And actually, when I first showed Sarah about vibe coding, and she's like, "Oh, this is going to be really this is going to be so dangerous for myself." And this is very true. So we have some general recommendations for how to approach vibe coding. First, we're going to have philosophical recommendations on like how to do vibe coding, and then we'll have some technical tips and tricks on vibe coding at the very end. So philosophical recommendations. I think the first thing that happens is that you start vibe coding, and then you have this psychological tendency to want to cut corners immediately. You just want to like, oh, this probably looks fine. This probably looks right. This probably looks like I don't need to review this. This is probably going to be okay. But we should not cut corners to maintain high quality science. And this is some things that I kind of are my current best practices that I kind of follow when kind of using AI tools to develop software, but also trying to maintain high quality science at the same time. First thing is you need to understand the code you write, even if you prompt the AI to write it. So, if you're contributing to an open source package, don't ever commit code that you don't understand. This is different from when you're just testing code, getting familiar with a package, or trying to understand something, right? Like when you're trying to make a contribution to a package, you should understand every line of code that you're contributing. This is especially important in the field of science. In science, our field and our kind of individual reputations as scientists is built upon the understanding of how things work. Science requires the understanding of how, not just like whether the final answer looks like what you think the final answer should be, right? And we need to understand the process. The process is what's important, and understanding inherently takes time and effort. There's not much you can get around it. You can't just be like, I don't really want to understand this. You have to sit down and understand as part of being a scientist. So that's kind of the number one thing. Was there a question?
I mean, is it in vibe coding if you're understanding every single line, or
the question is it vibe coding if you're understanding every single line? I would say it's still vibe coding, and I'll give you some examples. It's like I've maintained some open source packages, and there's like these obscure bugs that people find, and it's like, oh, under this version with this kind of setup, I somehow got this error, and it'll take me like probably 12 hours to go and like try to reproduce this error, do this. So I have the AI agent do all that. And it gives me a fix, and I look at the fix, and I look at the fix, and I'm like, oh yes, this will definitely fix that issue. So I'm understanding the changes it made, and understand that these changes should fix the issue and shouldn't impact the rest of the code. But I'm still doing vibe coding in the process of getting there. You understand what I mean? The next philosophical recommendation, if I can't emphasize this enough, is that you should review every line of code generated by AI tool. A great quote from Linus Torvalds, the creator of Linux. You need to understand not just your prompts, but you need to understand the end result too, because that's the only way you can maintain it long term. And this is especially appropriate for Code Astro when we're talking about trying to make open source packages for the astronomy community. It's different than trying to write a proof of concept demo code that you're like, oh, can I get this working? Yes, no, right? And then you're like, oh, I got it working. This is great. If you want to maintain something long term, you have to be able to reason through that code, understand 3 years later, why is this thing breaking? You have to be able to solve that, you have to have a fundamental understanding of the code itself. And there's no other way to do that other than you yourself reading the lines of code and understanding what those lines of code do. If you're contributing to a repository, please review your changes before you submit a pull request. This is a new rule I'm instituting for the open source software packages that I maintain. For any contributors, you have to review every line of code, even if it's especially if it's generated by AI agent. And a pull request, if you guys haven't heard about this thing before, a pull request is something is basically submits a chunk of new changes for a maintainer to consider. You guys may use some of these. Maybe you'll see them tomorrow in our extended Git lesson, but this is a implement that we can use to basically contribute new pieces of code. And anytime you're contributing code, review all your changes beforehand. And if you are reviewing code and you're the open source maintainer, you have to review every line yourself. Running an AI tool on it is not the same as reviewing yourself. I've been experimenting with vibe coding in preparation to teach this lesson, and I've been trying to find ways to use the AI agent to help me review code, but it's actually very bad. The things it gives me are I would say is no replacement for basically reading the code myself, basically. So I think that's a very important aspect of vibe coding. Um, and you are responsible for the code, even if it was made by an AI agent. So science is a human endeavor, and we scientists use tools to accomplish these tasks. AI can be one of these tools, but it's still the scientists that produce good science. So it's not the tool that produces good science. It's you that's producing good science. So you can't hide behind these tools. You want to take responsibility for these. And this comes all the way back to kind of trying to be lazy and speed things up. The physical act of writing code is just one part of the software development process. Like physically typing things in onto your text editor is only one part of the software development process, which AI can speed up with these generative AI tools and vibe coding. But it doesn't speed up other aspects of software development, like understanding the code, internalizing the code, architecting the code, structuring the code, trying to determine the purpose of the code, trying to figure out what problem you're trying to solve with the code. These are all parts of software engineering, right? But these aren't the things that vibe coding is trying to solve, or they're not particularly that good at solving, I would say. Because of this, vibe coding doesn't speed up science or programming by orders of magnitude, but it can speed up software development. It just only speeds up one aspect, one aspect that does take a lot amount of time, but it only speeds up one aspect. There's still other aspects of software development that it is not speeding up that we still have to do. So don't think of it as like it's completely automating the entire train. It's a very slippery slope. It's very easy to be like, oh, it can fix issues. Like Claude, you just saw me like just copy and paste for Claude Code, address this issue, and just gave it a GitHub link and just did it. It's very tempting to be like, address this issue, address this issue, address this issue, address this issue, commit, push, right? It's very tempting to do that, but you can't do that because that's not understanding the code, and that's skipping parts of the software development process. Generative AI is particularly strong at programming compared to other tasks. So not everything can be solved by AI. You're going to see if you do this that it's surprisingly good at many of these tasks. But don't let that to believe that it can solve any problem in the world because it's very good at programming. Programming is an extremely structured language, and large language models are very good at extremely structured languages. So this is why it's very good at programming. At Code Astro in general, we don't endorse tool shaming of any kind. So we shouldn't make anyone feel bad whether they use or don't use AI, whether they choose to use AI or they don't choose the AI. That's their personal decision. We're just we want to accept all people who are doing astronomy software development in any way they want. We're just offering some recommendations and how we think we're suggestions about how you can go about doing things. All right. Final stretch. We're almost done. Wow, this is longer than I thought. Vibe coding tips. These are just little tips about like how to do vibe coding. And sometimes it makes it a little bit more effective. Vibe coding tools that can integrate into an IDE are generally much more powerful and more capable. They do carry risk though. Basically, they can access your entire machine, delete files, read files you didn't want them to read, proprietary data, things like that. But I've been using Claude Code because it is more effective in that way. LLMs in general are much better at smaller and more focused tasks. So vibe coding tools like Claude Code, you just saw that live demo. It was breaking up that task into a bunch of smaller tasks and basically doing those smaller tasks and then basically do that bigger task, basically. Yeah. So the question is, can you restrict Claude Code to only specific folders? And the answer is generally yes. It depends on who wrote the vibe coding tool and how much you can restrict things, but generally they offer some amounts of restriction. LLMs can also perform worse as context increases So basically, as your chat histories get longer and longer and longer, LLMs will actually, you'll see their performance get worse and worse generally, vibes based, you'll see it get worse. And this is just based on the fundamental nature of how they're built. There's this thing called a concept called attention in LLMs. It's basically how many things can they hold on to, and the amount of resources, the amount of memory, the amount of various degrees of freedom you need to hold on to more and more attention scales in a very exponential way, basically. So as you go to longer chat logs, longer problems, you'll find that it starts performing worse and worse. So oftentimes you'll see you might want to start a new chat to start a new performance. You want to break up your problem into smaller tasks to ask it to do smaller tasks. And for some of these chatbots, there's a function feature that's like summarize or compact the chat history into something smaller that you can feed into the chatbot later. LLMs are generally better at pure programming problems and generally less good at knowing how to handle external state. And what I mean by external state is like, let's say we're trying to analyze some astronomical data, but like we know from looking at the data that, it only has a few image artifacts, but the data is really low signal to noise. Like there's a lot of noise and barely a blip. We know that, but it's really hard for an LLM to understand that context. Because of that, it may not be able to understand, like what kinds of bad pixel mapping algorithms should we use? Or, should we be using the maximum value? Because the maximum value could be noisy because there's a lot of noise in the data. Because of that, it probably you as a developer should make those decisions beforehand. Tell it that, this is some really noisy data. You should avoid using the maximum because the maximum can be very noisy. You should use some sort of average statistic instead, and basically guide it along those ways. Otherwise, it will have really a lot of trouble understanding context and figuring out those things. As a corollary, LLMs are actually very effective at pure programming problems. And I've personally found it to be very useful as a single person maintainer of an open source package, because over time as an open source package, you kind of accumulate kind of pure programming bugs. Like this thing doesn't work for Python 3.12, or like this H5, like this dependency that it uses when it's called in this way causes this weird error. These things that maybe takes you several hours to address because you kind of have to understand all these technical specifications. But these technical specifications are all kind of very laid out in a way that's very effective. What LLMs are very effective at addressing. So that's a kind of a corollary at, these are good problems for LLMs to deal with that you don't have to deal with, and maybe you can focus more on the science and how the scientific part of your package works. LLMs are like creating very condensed one-line solutions to programming problems, which I find, at least the ones I've used, which I find really hard to read, like to actually understand what the code does. It like compacts 4 or 5 lines, maybe an if statement, an else statement, a while statement all together. And I look at it being like, I have no idea what this line is doing. So you can discourage them from doing so or ask it to rewrite those changes. So that's part of the understanding the code, is also changing the style in which the code is written so that it's easier to be maintained in the future. Some of these vibe coding tools like Cloud Code lets you set up instruction files in packages, and that you can use those to provide guidance, such as don't write one-liner solutions to your problems, or only capitalize these particular words, things like that. That it can. But I've also found that these are just generally suggestions, and I found that the LLMs do break these suggestions. So nothing you put into one of these instruction files is set in stone, I would say. All right.
Can you give it something easy, like just maximize the readability for a human?
Maximizing readability for a human is a very ill-defined concept in which it will interpret in its own way. The question was, can you just give it something easy like maximize readability for a human? And I think that's maybe too vague of a thing for it to know exactly what you want, basically. All right, we're almost done. Sorry, we're running a little over time. Last thing is, general thing I like to do with LLMs is first prompt it to plan changes, and then it will output you a list of plan changes. You can edit that list of plan changes as you want based on your specifications, and then ask it to basically follow that plan and edit your files according to those changes. This is what Cloud Code does under the hood to some extent, but it's more effective if you force it to do it explicitly, and it gives you a chance to basically plan things at a higher level. And for even better, if you can even write down a list of requirements or a design document or a list of tests it needs to pass, just again, the more structure, the more specification you give it, the better it will do, basically. All right. That was the end of my rant. We are a little bit over time, but happy to take any other questions if people have them. Maybe just we can talk afterwards or put them on Piazza, basically. But thanks everyone for attending. This is our first time we did a vibe coding lesson, so we will be interested to hear your feedback on it too as well. Thanks.